Okay, let's unpack this. Imagine an AI that doesn't just teach you, but genuinely knows how you learn. It understands what makes you stumble, predicts when you might forget a concept, and adapts its entire approach just for you. That feels almost magical, doesn't it? Today, we're pulling back the curtain on the incredible journey of designing and building these personalized AI tutors. Our mission for you, the listener, is to walk away with a crystal clear understanding of the intricate decisions and components that truly make these systems personalized and, well, effective.
Yeah, and what's fascinating here is that we're talking about much more than just, advanced algorithms. It's really about deeply understanding the science of how humans learn. The source material for this deep dive offers a really robust roadmap,
Yeah.
expertly balancing the technical capabilities with sound pedagogical principles. It lays out the complete process, from the very first concept all the way through to deployment and, importantly, the ethical considerations that have to guide every step.
So let's jump right into this fascinating journey of AI tutor development. And just like building a truly personalized home, you can't lay the foundation until you know exactly who's going to live there and what their life will look like. That brings us to phase one, the foundation discovery and definition. Before anyone writes a single line of code, you have to precisely define who this AI tutor will serve and what it aims to accomplish. This foundational phase is absolutely paramount, right? It shapes every subsequent design decision.
Precisely. Our guide breaks this down into three core pillars that are kind of like the architectural drawings for our smart home. First, we have user specification. This means defining the learner's profile with incredible precision. Think about their age, current educational level, their prior domain knowledge, like what do they already know or not know. Then you have practical considerations like language proficiency, any accessibility requirements, even their cultural context, which can significantly influence learning styles and interactions.
Okay, so really getting specific about the person.
Exactly. Second are the learning objectives. These can't be vague aspirations. We're talking about specific, measurable competencies the learner needs to master. You need clear success criteria. How do you actually quantify mastery? Along with robust assessment standards and, crucially, alignment with existing curricula. This stops the tutor from just teaching in a vacuum, disconnected from broader education goals.
Makes sense.
And finally, scope definition. You absolutely must clarify the boundaries. Is this tutor for a comprehensive course, like an entire semester of calculus? Or is it for a targeted skill, maybe mastering quadratic equations? What's the depth versus the breadth of coverage? Are there time constraints? And how will it integrate seamlessly with existing educational systems? The key takeaway, really, directly from our source, is that the most effective AI tutors come from clearly bounded domains with well-defined, measurable learning outcomes.
Wow. This foundational work feels almost more crucial than the coding itself. Is it fair to say that many AI tutor projects might falter not because the tech is too hard, but because there's a fuzzy understanding of who they're really for and what they truly need to learn?
Absolutely. I think that's spot on. Without that clarity up front, you're building on sand. It's where many well-intentioned projects can just veer off course before they even properly begin.
That makes perfect sense. Okay, so the AI has a clear understanding of who it's teaching and what they need to learn. But for it to be truly effective, it needs a teaching philosophy, right? It needs to understand how to teach. This brings us to phase two, the brain's curriculum and pedagogical design, where the AI actually learns to think like a teacher. This is where I find it genuinely fascinating.
Indeed. And this phase has two main aspects that define the AI's instructional intelligence, if you will. First, domain knowledge structuring. So you decompose the subject into individual competencies and learning outcomes. Then critically, you map out the prerequisite relationships between these concepts. You're essentially creating a knowledge graph that shows dependencies like what a learner needs to grasp before moving on. You also develop exemplar problems, worked solutions, and really important, identify common misconceptions, which are vital for designing effective remediation paths.
So anticipating where students might get stuck.
Exactly. The second aspect is pedagogical strategy selection. This defines the AI's teaching style. Will it primarily use direct instruction, just presenting information clearly? Or maybe employ Socratic questioning, guiding the learner to discover answers themselves? Our source mentions using work examples with progressive fading where initial support is gradually removed as they get it, and things like spaced repetition scheduling for optimal retention. Retrieval practice, where learners actively have to recall information, is also key for strengthening memory. And finally, there's this delicate balance between allowing the learner to explore on their own and providing clear guidance when they need it. If we connect this to the bigger picture, this is really where the AI's teaching style is defined. moving far beyond simple information delivery to truly adaptive instruction.
Exactly. It's about embedding deep pedagogical wisdom into the system itself. But that wisdom only becomes truly powerful when the AI can apply it to you specifically. How does it manage that? This brings us, I think, to phase 3, knowing you learner modeling. This is where the AI starts to build a dynamic understanding of your unique learning journey.
Yes, and this is fundamental to personalization. It typically begins with an initial diagnostic, often a pretest, to estimate your prior knowledge across the curriculum and establish a baseline, identifying any initial gaps. Then, the AI uses knowledge representation. It tracks proficiency levels for each concept, often on a scale, say, from 0.0 to 1.0, and even confidence intervals to reflect any uncertainty in that assessment. And this isn't static. It uses continuous assessment, dynamically updating your profile based on your performance. It even incorporates things like forgetting curves, the natural way our memory declines over time, and knowledge decay models to predict when you might need a review. It's kind of like a very sophisticated flashcard system.
Wow. So what exactly is it tracking then?
Well, the learner model keeps tabs on quite a bit. Conceptual mastery per topic, certainly, but also your affective state and engagement patterns like are you bored, frustrated, or deeply engaged? Your learning preferences, response times, and hesitations, your error patterns and common misconceptions, and even practical things like device and time constraints.
That's a lot of data points.
It is, and this model is updated constantly. We're talking about update mechanisms at multiple frequencies. There are per-question updates for immediate proficiency adjustments, per-session updates for analyzing engagement and interaction patterns, weekly updates for looking at long-term retention, and continuous Bayesian updates. That's a statistical method that revises probabilities as more evidence comes in with each and every interaction. This raises an important question. How fine-grained can this understanding get? The answer, as you can see, is potentially incredibly detailed, adapting almost moment by moment to you as a learner.
This real-time adaptation sounds incredibly powerful, but it also raises a question for me. How do we ensure the AI's interpretation of a learner's affective state is truly accurate? I mean, isn't there a risk of it misreading someone and then intervening in an unhelpful way?
That's a crucial point, and it's a real challenge. That's why these models often use multiple signals, not just one thing. And they use those confidence intervals we mentioned. No single data point is usually taken in isolation. The goal is more of a probabilistic understanding, not a definitive psychological diagnosis. And generally, the aim is to err on the side of supporting the learner, even if the affective state isn't perfectly clear. You build in safeguards.
Okay, that makes sense. It's fascinating how much data goes into that picture. So now that the AI knows you, how does it effectively adapt to you? Let's dive into phase 4. Tailoring the experience personalization dimensions. This is where the learning journey truly becomes bespoke, right?
Exactly. This is where the adaptation rules really come into play. And effective AI tutors adapt across multiple dimensions. For content selection, for instance, the AI chooses topics and activities based on your current mastery and any identified gaps in prerequisite knowledge. So a clear rule might be something like, if prerequisite mastery for concept X is below 0.7, then review foundational material before advance to concept Y.
Right, logical steps.
Then there's difficulty adaptation. The system adjusts the challenge level, maybe using item response theory, which basically calibrates questions very precisely to your ability level to maintain optimal difficulty. The goal is ensuring you're neither overwhelmed nor bored. Example rule might look like, after 3 consecutive correct answers, increase difficulty by, say, 0.15 to keep the learner in that optimal challenge zone.
The sweet spot.
Precisely. The feedback approach is also highly personalized. The AI can vary the style, timing, and detail of its feedback based on your preferences and performance. For instance, if an error seems conceptual, the rule might be to provide a worked example rather than just a hint, guiding you more deeply into the why.
Okay.
And finally, pacing and scheduling. The AI can adjust session length, how often reviews pop up, even response timing based on your individual learning patterns. For instance, a rule could be schedule review of a concept when its retention probability drops below, maybe 0.8, actively preventing forgetting by re-engaging with the material just when you need it most.
These are the rules that make the AI feel like it's speaking directly to you, almost anticipating your needs. It really does sound like a conductor orchestrating a complex symphony of learning experiences. But this level of precision must be incredibly challenging to manage across thousands, maybe millions of unique learners. What's the trick to that orchestration? How do they scale that?
Well, the trick is a combination of robust system design and crucially careful iterative testing. You build these rules, absolutely, but then you have to constantly refine them based on real-world data. You need to ensure they actually lead to measurable learning gains, not just perceived personalization. It's an ongoing process of optimization and validation.
That makes sense. It's not set it and forget it. Okay, let's take that peek under the hood then for phase 5, the engine room technical architecture and implementation. What are the core components that actually power these intelligent tutors?
Right? On the technical side, the source highlights several core components. You typically have system orchestration, which kind of directs traffic, routes requests, and enforces policies. There's usually a dialogue manager that tracks the context and the state of the conversation. Crucially, there's often an LLM engine, a large language model for generating explanations, feedback, and responses. And this often works alongside a retrieval layer, sometimes called RAG, Retrieval Augmented Generation. This helps the LLM pull in accurate, authoritative content from a knowledge base to ensure factual correctness, which is vital in education.
So the LLM isn't just making stuff up.
Hopefully not. That's the goal of RAG. Beyond these core parts, there are supporting systems, things like the learner model and profile database to store all those proficiency levels and preferences we talked about, an assessment engine for creating and grading quizzes and exercises, an analytics platform to track KPIs and run experiments, and critically, safety filters to prevent harmful content or interactions.
Got it. A whole ecosystem.
Exactly. And for implementing personalization mechanics, the AI relies on various input signals. These include performance metrics from assessments, sure, but also interaction patterns like time on task or how often you use hints, sometimes explicit preferences you might set yourself, contextual metadata like the device you're using or the time available, and potentially even those affective signals we discussed, though they need careful handling. It's really important to note, the source emphasizes accounting for noise and uncertainty in these signals, building confidence intervals into your learner model because real-world data is rarely perfectly clean.
Right, dealing with fuzzy data.
And when it comes to the actual adaptation mechanisms, how the system decides how to adapt, there are 3 main approaches outlined. The simplest is rule-based, using explicit if-then conditions based on threshold values. Pretty straightforward, but maybe the least flexible. More sophisticated is model-based, which uses predictive models trained on historical learner data. This requires more data, but is significantly more adaptive. And finally, the most powerful, but also the most complex, is often reinforcement learning. Here, the system learns optimal instructional policies through exploration and trial and error, almost like an AI learning to play a complex game, but the game is teaching effectively.
So it's truly a symphony of different technologies working together. You've got the generative power of LLMs, sophisticated tracking systems, databases, and these different philosophies on how that adaptation actually happens, rules, models, or even learning by doing, each with its own trade-offs between simplicity, data needs, and ultimate power. It's incredibly complex stuff.
Okay, so building it is one thing, a massive undertaking. But how do we definitively know if it actually helps you learn better? That brings us to phase 6, proving it works, the evaluation framework.
Yeah, this is absolutely critical for any effective AI tutor.
Yep.
Our source really stresses the necessity of implementing proper A/B testing methodology. You need control groups to rigorously isolate the impact of specific personalization features. Without these controlled experiments, you simply cannot reliably attribute learning gains directly to your system. You might see improvement, but you don't know why. You're just guessing it was the AI tutor.
So proper science. Exactly. The evaluation framework uses a multifaceted approach with several key metrics. First, and most importantly, learning outcomes. Things like pre-post knowledge assessments, retention tests conducted after some time has passed, and looking at how well the learner can transfer knowledge to new, different problems. Then, engagement metrics are tracked. Session duration, how often users come back, completion rates for modules or tasks, and voluntary engagement, do they use it when they don't have to.
Okay, so learning and usage.
Right. We also look at system performance, things like the quality ratings of responses, error rates, and how well the system recovers, and the perceived appropriateness of the adaptation decisions. Did the difficulty change feel right to the user? And a crucial aspect, increasingly so, is fairness and inclusion, assessing performance across different demographics, ensuring accessibility compliance, and actively detecting any bias in feedback or adaptation to make sure no group is inadvertently disadvantaged.
So it's like a truly scientific experiment, multiple times over, to prove the value. Ensuring these tutors genuinely improve learning for everyone, not just engagement or time spent on the platform. That rigor is essential for trust, I'd imagine. Now, beyond the impressive technical and pedagogical marvel of building these systems, What are the crucial human and ethical responsibilities in bringing them into the world? This feels like the really big picture, ethical considerations and best practices.
Absolutely. And arguably the most important part. The source highlights four key ethical pillars that must guide development. First, privacy and data protection. This means minimizing data collection, only gathering what's strictly necessary for personalization and function. It means having proper data retention policies, allowing learners control over their profiles, and providing transparent explanations of how their data is being used.
Yeah.
It's fundamentally about respecting the learner's digital autonomy. Second is safety and content moderation. This includes robust content filters to block harmful interactions, actively monitoring for potential misuse or unexpected harmful outputs. Establishing age-appropriate guardrails is key, especially for younger learners, and having clear reporting mechanisms for any issues that users encounter. We have to ensure a safe learning environment.
Non-negotiable.
Third, fairness and inclusion. Developers absolutely must test these systems across diverse learner populations. They need to monitor for differential performance to ensure no group is systematically disadvantaged, adjust algorithms if bias is detected, and actively design the tutor to support multiple learning styles and backgrounds. Education tech should broaden access, not narrow it.
Critical point.
And finally, transparency and agency. Learners should have the personalization explained to them, at least at a high level. They should ideally be provided some control over the adaptation features, maybe opting out of certain types. They need to clearly see their progress and understand the rationale behind the AI's suggestions. It's about balancing effective guidance with genuine learner choice and empowerment. The ultimate goal, as the source reiterates powerfully, is to empower learners, complement human teaching, and foster genuine understanding, not just push them towards shallow task completion.
This is perhaps the most important part, as you said, ensuring that these incredibly powerful tools are built responsibly and truly serve the learner's best interests. Given these crucial ethical considerations, where do you see the biggest tension arising for developers in practice? Is it that privacy versus personalization trade-off? Or perhaps ensuring fairness in assessing diverse learners accurately?
That's a great question. And I think often the tension lies precisely where you suggested, that intersection of personalization and privacy. The more data you gather, potentially the more exquisitely personalized you can make the learning experience. But that obviously comes with significant privacy implications and risks. Balancing that potentially optimal experience with robust data protection and user trust is a constant challenge. It requires continuous vigilance, a deep commitment to ethical design principles from the outset, and probably ongoing dialogue with users and educators. Fairness is another huge challenge, ensuring the algorithms don't inadvertently replicate or even amplify existing societal biases.
I walk, really.
It really is. And if we connect this all back to the bigger picture, designing an effective and responsible AI tutor is clearly less about just coding and much, much more about a holistic understanding of pedagogy, psychology, data science, and ethics. We've explored a comprehensive journey today, haven't we? From precisely defining the learner and their goals, to structuring knowledge, building those dynamic learner models, designing adaptive interactions, implementing robust technical architectures, and rigorously evaluating effectiveness, all while keeping those crucial ethical considerations absolutely central. Ultimately, these systems are designed to enhance, not replace, human education, to augment the capabilities of teachers and learners.
So thinking about all this, as AI tutors inevitably become more sophisticated, how might this change our traditional understanding of the classroom or even the teacher itself? What new opportunities or perhaps what new questions does this raise for your own learning journey or how you think about education? We hope this deep dive has provided you with a richer understanding of these transformative technologies and maybe some insights into how you might engage with them in your own educational pursuits or just understanding the future of learning.